Now, direct variation, as one variable is getting bigger, so is the other one. One very simple equation that we are going to focus on is this one right here, y equals kx. Now, we know that's a linear function. It looks a lot like y equals mx plus b. What's the b? What's the y-intercept in the equation in the purple, the y equals kx? It is a 0. The y-intercept is a 0, which means that when we graph these things, we should be looking at something that goes through the origin. When we graph these lines, they will go through the origin. Y equals kx will always go through the origin because that y-intercept is 0. Now, the points that I'm circling in blue down here are normally irrelevant to story problems. Why are they irrelevant to story problems? Make sure you're taking notes on this stuff. Like when we start talking about, when I go to the gas station. Yeah, like if I go to the gas station, I want to buy gas for my car. I'm not going to have a negative number of gallons, and they're not going to charge me a negative amount of money. Otherwise, they're paying me. Yeah, that would be great.
Gas is like
I'd go to the gas station every day.
Yeah, I want to go get paid. I'm going to the gas station. Now, so that portion of the graph is truly in our story problems not relevant to us. Okay? I need to keep going. What?
Wait, off topic.
I know.
We were talking about gas stations. How much do the gas stations have to pay more than we do to get their gas?
No, they make a small amount of money on the gas. They make the most amount of money on the convenience items they sell in the store.
Yeah.
That's where they make their profit. Well, it's amazing the amount of people who buy things like candy bars and Gatorade and things at a gas station, and they're spending a lot of money. Okay. It's just you're spending way too much money on it because you're getting it there versus buying it at Meijer or Walmart and then just refrigerating it yourself. I mean, you're paying for the convenience, but you pay through the nose. Okay. Now, I need to continue with the direct variation conversation before we switch to the inverse. You'll notice that the k value, here labeled as it's called the constant of variation. What? The constant of variation. You know it's the slope of the line. You writing this down? You turn that computer, it makes me think you're just trying to avoid me. And that's where we end up with zeros on the notes. All right, now.
Wait, what did you say about the K?
The K is the slope of the line. So it's like the price per gallon. When you go to the gas station, the number on the sign is the slope of the line. Okay, so the one thing that you really need to realize as x is getting bigger, that music probably needs to be turned down. It's a little bit too loud for me since I can hear it. As x is getting bigger, so is y. Makes sense because if I put more gas in the tank, I'm going to get charged more money. I guess it depends on which side of the equation you're on there.
So as x gets bigger, y also increases.
Yes, they go together. As one is increasing, so is the other one. That is not true when we get to inverse variation, and we'll talk about that in a minute. Can you... Yeah, that squeaking is really getting annoying. If you were going to solve this equation, for k, what would you get if you took this equation and solved it for k? Well, not y minus. You can't move the x to the other side by subtracting. y divided by x. Now, the important thing that you need to realize out of what we just wrote is that every time you take a y value and divide by its x value, you get the exact same number. That's why they call it a constant. If you go to the gas station, right, and I take this person's bill over here, I take the amount of money they spent divided by the number of gallons they got, and then I go to somebody else at the gas station who got a different number of gallons of gas and had a different total cost, and if I take the amount of the total bill and I divide by the number of gallons, guess what I get? That number you see in the digital red letters up on the sign. It's the slope of the line, right? It's the constant. Every single one of us at the gas station is paying the same price.
It was $2.90.
I know. One day it was $2.69, and the next day it was $2.99. I was like, "What the heck?"
When I filled up, it was like $3.05.
It's amazing how it jumps around. Okay, now
I drove all the way down 24 just to get gas because it's cheaper.
inverse variation looks different. Y equals k divided by x. This is a different relationship. When we do the graph of this one, we get something that looks like this. If you do, as long as I can see what you're writing when I get done. That's fine. You can use the inking feature.
Will it ever touch the axes?
No, it will not. Good point. There's something called an asymptote going on here.
So the inverse never touches, but the direct variation does.
Correct. Direct variation does go through 0, 0, because if I go to the gas station and I don't put any gallons of gas in my tank, they're not charging me anything for standing there. They might get a little mad.
Yeah, taxes.
Taxes.
It's that new air
Land
tax.
taxes.
Air taxes.
What if we owned all the water?
Okay, now,
They call the cops and waste their
why does this portion of the graph not matter to the story problems?
Because you can't go negative.
We won't have negative numbers in these things. Okay, so here's a situation for you, which is an inverse situation. Suppose you worked for a car lot, and they told you that the car dealer has 100 cars, and they want you to wash every one of them. Okay? So, it's going to take you a while, right?
Mm-hmm.
Let's say it took you a half an hour to do the good job on each one. So it's going to take you 50 hours to do 100 cars. What if a friend of yours who is of the same, I'm going to make an assumption here that friend also is the same level of worker that you are. Same work ethic, same skill level, all that good stuff. Okay, that's an assumption I'm making. If the two of us are working together on this project, what happens to the time?
It's cut in half.
It's cut in half. We go from 50 hours to 25 hours, right? So what if 1, 2, 3, 4, 5 of us now are working on the project? 10 hours. In other words, as the x is increasing, the y is decreasing. Okay? What if 100 of us?
No.
Take 30 minutes because we'd each do our own car. So all I'm getting at is that inverse as one's getting bigger, the other one's getting smaller. Yes.
So you're telling me if John and I worked on a car dealership, it would probably take us a decade. Because John's work ethic.
Attack.
I thought it was 'cause
Seriously.
you had tiny hands.
I thought it was just because of the amount of arguing that would happen.
Yeah.
Oh, we'd argue.
We wouldn't argue.
Oh, yeah. If it was me and Big Shrek,
You're supposed to wax left, no,
wax on.
Okay, now,
You go this way.
another way.
Redo.
Please do me a favor and solve this equation for k. Take that equation and solve it for k. You would multiply by x. So, let's go back to our example with the car dealership.
So would X be
All right? If one person does all the 100 cars, right? We said it would take 50 hours. What's 1 times 50?
50.
Then we said if 2 people did it, you told me 50, it would go down to 25. What's 2 times 25?
50. That's a constant.
If 5 people did it, you told me 10 hours. What's 5 times 10?
50.
If 100 people did it, you said it would take 30 minutes. What's 100 times 0.5? 50. The constant keeps showing up. That's what you were using each time. You just did it quickly in your head.
Whoa, that's crazy.
I know. Okay, let me see if there's any other detail I wanted to tell you about. Okay, let's go back up to question 1. Question 1 says, do the data in each table represent direct variation or inverse variation? Now, in other questions, I'm also going to give you a third option, which is neither. Okay? So, okay, as x increases, y increases. Now, one good hint that we just got from behind me is that his suspicion is that this is direct variation. Okay, now, it could be neither, but obviously in this choice they only gave me 2 options. So you would know right away. But I'm going to add 2 columns to this table.
Wait,
Yes,
which
2
direction
columns.
do you add?
It doesn't matter which side you put them on. Okay? And in one of these columns I'm going to do y divided by x, and in the other one I'm going to do x times y. Now, what is, if I'm doing y divided by x, is that direct or inverse? Look back at your notes. What did it say? Which one is y divided by x?
That's direct.
Ah, right down there, y divided by x. That goes with direct.
The first one you get 0.2.
Okay, oops, sorry.
And then 0.25 again. It's a constant.
Okay, so we've got an inverse, right? Now, if I take y and I divide by x, 0.5 over 2, what do I get? You said it out loud, Mr. Bond.
0.25.
Ah, 0.25, thank you.
That's the constant.
What is 0.5 times 2?
1.
1. What is 1.5 divided by 6?
0.25.
0.25. What about 1.5 times 6?
9.
9.
So that y over x is the constant.
And if I divide 2.5 divided by 10, I get 0.25, right? And if I multiply them together, I get 25. Do you see why it has to be direct?
Because the same number.
Same number showed up every single time. So, if it's direct variation, what's the equation? Y equals what times x? Yeah, what do you think k is? 0.25. There is the model.
You have to check that.
You don't need to check it because you already checked it 3 times with the data right there. Okay? Now,
Wait, you're telling me that if it would be indirect, it would be consistent? Or would it be
okay, if it was inverse, then these numbers over here would have been the same. However, within the first 2 coordinates, I saw that I had a 1 and a 9. I ruled out inverse pretty quickly. Now, you actually had a really good reason to rule out inverse completely because you said as x is getting bigger, so is y. That would never happen with inverse. However, it would not get rid of your neither option if that was a case, if that was an option in this particular case. It was not. They said direct or inverse, so we know it's direct, and y equals 0.25x. Okay? Inverse, direct, or neither. Okay, so we're going to make our little, let's see here, y over x, and our x times y. Okay, so when I do y divided, or 3 divided by 4, what do I get? 0.75. How about 3 times 4? 12. 6 divided by 8. 0.75. 6 times 8. 48. So this is obviously not what?
Inverse.
Not inverse.
So it'd be 0.75x.
What is 9 divided by 14? And that's where you would be wrong. What is 9 divided by 14?
0.64.
0.64. It's not direct.
So it's neither.
So it's neither, that's right. Okay, so I knew the first two you were going to bite on and say direct. Because you saw 0.75, 0.75. Oh, the next one has to be 0.75. Not necessarily. I know, because they don't like you.
Well, what's 12 divided by 6?
Okay, all right. Well, that's good. That's good.
So if one's not what the others are, it's
Still a neither. Still a neither. Now, if it's a neither, what about the second part of this question? If the relationship is direct or inverse, then write an equation. Choice C. There is no equation. How can I come up with an equation if it's neither? Okay, we're not going to do this because it's pretty much a duplicate of the last one, so that was accidental. Grass. Huh? What? I'm lost. Okay. X and Y vary inversely. Did they just tell me Y equals K times X, or did they just tell me Y equals K divided by X? They did. They did just tell me that, didn't they? This was not true. Okay. They are asking me to write an equation, and they want me to figure out what K is. Why do you think they gave me this information right here? Ah, so we could plug it in. So if I plug it in, what's the value of K? Any thoughts? Somebody said 11. Is that true? It is true. So there's my answer to that question. Y equals 11 over X. They asked me to graph it. Can you tell me two that I should throw out immediately? C and D. We're not talking about direct variation, folks. We're talking about inverse variation. Right, those others are direct. So we need to look specifically at these two choices. Now, if I use the third mark from the right, what is that third mark from the right? 6, right? They go by twos. Would you say that this place right here is equal to 2 or just a little bit smaller than 2? Just a little bit smaller. Okay, so go to your equation, 11 over x, and put a 6 into it. What is 11 divided by 6? 1.83 approximately, right?
1.83.
Okay. Is that number a little bit smaller than 2?
Yeah.
So ding, 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 we found it. If you come over and look at the other one, at 6, what's it telling you that you would come up with? A little bit under 4. That's how I knew this was not the right choice. Because it's telling me a little bit under 4, but my equation is clearly telling me a little bit under 2. So I knew that that had to be the right one. When I was looking at the graph right here, I could see that the curve, when it got to the 6 mark, was just underneath 2.
Right, but how do you know that was 6?
Because it goes by increments of 2. So this is 2, 4, 6,
Oh, okay.
8, 10, and 12. Okay? So I knew that it was going by 2s, and so I knew it was just a little bit less than that. Now, they also ask me to find what is the value of y when x is 20. I'll take your answer as a fraction or a decimal. Fraction or a decimal. Fraction or decimal? What you got? 0.55 as a decimal is true. And what would that be as a fraction? 11 over. Hey, all I had to do was plug in a 20.
Great.
Yeah, I know. I'll take either one of those, right? It's true. All right, folks. Question 5. In a bake sale, you recorded the number of muffins sold and the amount of sales in a table as shown. What is the function? Now, using that super sleuth skill on the that you were talking to me about the as x gets bigger, what happens to y? Can you tell me if this is going to be direct or inverse? Direct. Okay. So we know it's direct. You come up with the equation. Number 5, I believe. Come up with the equation. Y divided by x gave me what? 2.5. That's true. Suppose I want $250 in sales. You know what? Let's go crazy. Let's go $2,500 in sales. $2,500 in sales. We've already decided if we can sell 2,500, that's our goal. That's $2,500 in sales. How many muffins do you need to sell? How'd you get that? Plug what in? We're not adding all the numbers up. I mean, when plug it in for the sales. Okay.
Do you divide by 2.5?
Yep, that's what he did.
Yeah.
Now I understand they said 250, and that's why this is 100. Okay. I just picked 2,500 because I wanted you to think. You know, think big. Looks like it says 2,500 or 250 right here. But it would be 100. I just multiplied by 10, just, you know, to think bigger. Okay. Question 6, you've been told it's direct variation. Find y. All right, now there's 2 different ways to do this. One of them looks like this, and then Ms. Frederick showed me a different way, which some of you might have also come up with as well. Okay, make sure you're writing this stuff down. So the one way to handle this is to know that it's direct variation. Okay. And if we have a 5 for y and an x of 4, then we can come up with a k value of 5 over 4. Some of you already know that's 1 1/4. And whether you use the decimal or the fraction version, then you plug in your x value and you calculate your y value and you get 20. All right, several of you got 20. Okay, now there's another way to handle it, and this is the way Miss Frederick did it. Okay, she realized that direct variation is k equals what? What did she remember? K equals what? Y divided by x. And she remembered that that means every single time you take a y value and you divide by an x value, you get the exact same number. So in her mind, she did this. 5 over 4 equals y over 16. The y value divided by the x value. Now, I know you probably wouldn't claim that you were doing that, but that is really what you were doing. You were doing cross multiplication in your head. And you were realizing, hey, if I do this to this, 4 goes to 16 is 4. I'll just take the 5 times 4 and get 20. Okay, that does work. Now, I'm going to challenge her when we get to inverse variation here in a second to use similar thinking and see if she can do it a slightly different way, because it will be different since it's inverse. Okay, in fact, let's jump to question 8. This is inverse variation, folks. So now I want you to try it kind of the way you were doing before, but you'll have to think about it. Okay, everybody else needs to find the value of x. The big screen for the viewers at home.
It's 21.
It is 21, and you can use either one of those methods to do it with, whether you use the xy equals xy, or you find the k value and then plug in the value of the new y value.